Hi students, how are you? Hope you all are keeping fine and safe. Today we deal with the chapter Light, Reflection and Refraction. In your last class you already studied about what is reflection. Okay, what is reflection, the terms related to reflection and the reflection on spherical mirrors, plane mirrors and also image formation by spherical mirrors and also the ray diagrams. Am I correct? Yes. So, today we are going to discussing the another term. Okay, the next term, refraction. Okay, refraction. Refraction of light. Okay, refraction of light. Light seems to travel along straight line paths in a transparent medium. Okay. What happens when light enters from one transparent medium to the another? Do you know? What happens when light travels from a transparent medium to another medium? Does it still move along a straight line path or change its direction? Do you know? We shall recall some our day-to-day life experiences. Okay. Do you all see ponds? Yeah, pond. Okay. You might have observed that the bottom of a water tank or pond containing water appears to be raised. Am I correct? Yes. What is the reason? Do you know? Another example. A thick glass slab is placed over some printed matter. Okay, some letters or anything. Some printed matters. The letters appear raised. Am I correct? The letters appear raised when viewed through the glass slab. Okay. Why does it happen? Another example. A pencil is partially immersed in water. Okay, partially immersed in water. We take a glass tumbler. Water is there. We immerse a pencil onto this tumbler. Okay. Pencil. We can see the pencil look like this. Can you see this? No? Okay, I will draw a big picture for you. Okay. A glass tumbler is filled with water. A pencil is immersed. Our pencil, okay, writing pencil. A pencil is partially immersed to this water. There is a change in the direction of pencil. We can see the pencil look like this. What was the reason? Do you know? Let me discuss the reason behind this phenomena. Okay. Let us consider the case of the apparent displacement of a pencil partially immersed in water. Like this. The light reaching you from the portion of the pencil inside water seems to come from a different direction. Okay, seems to come from a different direction compared to the part above water. Look like a different direction compared to the another part. Okay, above the water. This makes the pencil appear to be displaced at the interface. Okay, displaced at the interface. For similar reasons, the letters appear to be raised when seen through a glass slab placed over it. Okay, did you understand the reasons behind these examples? Everyday life situations? Yes. Okay, what is the phenomena behind this? Yes, that is the refraction. So, what do you mean by refraction? What is the definition of refraction? Or what do you mean by refraction? What is refraction? Based on this experiment or based on this, we can say that bending of light when it passes from one media to another. Here a light is passing. We can say that light is passing. Okay, light is passing. So the light is passing through this media. Okay, there is a bending of light. Okay, bending of light when it passes from one media to the another. Here the medium is air and here the medium is water. So the light is travel from air media to water media. So there is a bending of light. That's why we can see the pencil is displaced at the interface. Okay, did you get? That is the refraction. Okay, that is the phenomena refraction. We can say the definition of refraction is change in direction of light when it is traveling obliquely. Okay, obliquely from one medium to the another. Okay, the change in direction. We can say that the change in direction, the direction of pencil is changed. Okay, so the change in direction of light when it is traveling obliquely from one media to another, that is called refraction of light. Okay, that is refraction. Does a pencil appear to be displaced to the same extent if instead of water we use liquids like kerosene or turpentine? Instead of water we use kerosene. What happens there? Do you know? Will the letters appear to raise to the same height if we replace a glass slab with a transparent plastic slab? Earlier we said that a glass slab is put some letter you will find that the extent of the effect is different for different pair of media. Okay, the extent of the effect, the displaced effect. Okay, the extent of the effect is different for different pair of media. These observations indicate that light does not travel in same direction in all media. Okay, from this we can conclude that the light does not travel in same direction in all media. Okay, so it appears that when traveling obliquely from one medium to another, the direction of propagation of light in the second medium changes. The direction of propagation of light in the second medium is changed. Okay, this phenomenon is known as the refraction of light. Okay, let us understand this phenomenon further by doing a few activities. You can see some activities in your textbook, page number 172. Activity 10.7. Activity is place a coin at the bottom of a bucket filled with water. With your eye to a side above water, try to pick up the coin in one go. Did you succeed in picking up the coin? Repeat the activity. Why did you not succeed in doing it in one go? Ask your friends to do this. Compare your experience with theirs. You have to do this activity and you have to write your experience in your notebook. Okay, you have to do this activity and you have to write your experience in your notebook. The next activity is place a large shallow bowl on a table and put a coin in it. The next activity is place a large shallow bowl on a table and put a coin in it. Move away slowly from the bowl. Stop when the coin just disappears from your sight. Ask a friend to pour water gently into the bowl without disturbing the coin. Keep looking for the coin from your position. Does the coin becomes visible again from your position? How could this happen? This also you have to done. Okay, you have to do. The coin becomes. I will tell we will discuss discuss these conclusions in your next class. Okay. There is another activity. Draw a thick straight line in ink over a sheet of white paper placed on a table. Place a glass slab over the line in such a way that one of its edges makes an angle with the line. Look at the portion of the line under the slab from the sides. What do you observe? Does the line under the glass slab appear to be bent at the edges? Next, place the glass slab such that it is normal to the line. What do you observe now? Does the part of the line under the glass slab appear bent? Look at the line from the top of the glass slab. Does the part of the line beneath the slab appear to be raised? Why does this happen? These are the three activities you have to do. You have to do these three activities, okay, and write your experiences on your science notebook, okay. Next topic is refraction through a rectangular glass slab, okay. Refraction through a rectangular glass slab. Through a rectangular glass slab. Glass slab. Okay. A rectangular glass slab. To understand the phenomenon of refraction of light through a glass slab, let us do an activity. Fix a sheet of white paper on a drawing board using drawing pins. Place a rectangular glass slab over the sheet in the middle. Draw the outline of the slab with a pencil. Let us name the outline as A, B, C, D. I will draw this in our board. Okay. This is consider this is a rectangular slab and named as A, B, C, and D. Okay. Fix two pins, say E and F, vertically such that the line joining the pins is inclined to the edge AB. That is E, F. Okay. E, F. E and F are 2 point vertically such that the line joining to the pins is inclined to the edge AB. Okay, AB. Look for the images of the pins E and F to the opposite edge. Fix two other pins, say G and H, such that these pins and the images of E and F lie on a straight line. Okay, lie on a straight line. Remove the pins and the slab. Join the positions of the pins E and F and produce the line up to AB. Let EF meet AB at O. Similarly, join the position of tip of the pins G and H and produce it up to the edge CD. Let HG meet CD at O dash. Okay, AB. Let EF meet AB at O and let HG meet CD at O dash. Join O and O dash. Also produce EF up to P as shown by a dotted line. Okay, we can draw this figure. Okay, this is a rectangular slab. We name A, B, C and D. In this activity, you will note the light ray has changed its direction at points O and O dash. EF and it's inclined this is O and this is O dash and this is G and this is H. Okay. E, F, O dash, G and H. We note that both the points O and O dash lie on surfaces separating two transparent media. Okay, O and O dash lie on surfaces separating two media, air media and glass media, air media. Okay, to separate it. Two transparent media. Draw a perpendicular. Okay, draw a perpendicular, that is N dash to AB and O. That is here. We draw a perpendicular to AB. Perpendicular to AB. That is N and N dash. And also we draw another perpendicular to CD. Okay, another perpendicular to CD. That is M and M dash. Okay, M and M dash. The light ray at point O has entered from a rarer medium to a denser medium. That is from air to glass. This is air, this is glass. Okay. Air is a rarer medium. Okay. Air is a rarer medium. Air is rarer medium and glass is denser medium. Okay. Air is a rarer medium and glass is a denser medium. So the light travels from the rarer medium to a denser medium. Okay, light travels from a rarer medium to denser medium. And this here, the denser medium to a rarer medium. That is air to glass, glass to air. Okay. Note that the light ray has bent towards the normal. Light ray has bent towards the normal. Here, the light travels from a rarer medium to the denser medium. Okay. Light has bent. Light has bent towards the normal. Light has bent towards the normal. Okay, light has bent towards the normal. Bent towards the normal. At O dash, the light ray has entered from glass to air. Glass to air. Denser medium to rarer medium. So, the light here has bent away from the normal. Bent away from the normal. Bent away from the normal. Okay, bent away from the normal. Compare the angle of incidence with the angle of refraction at both refracting surface AB and CD. How to do that? Compare the angle of incidence and angle of refraction. Here, which is the angle of incidence? The angle of incidence is this I. Here we have two angle of incidences and two angle of refraction. So we denoted the first angle of incidence as I1. Okay, this is the angle of incidence. Angle of incidence. Okay, this is the angle of incidence. Angle of incidence means the angle between the incident ray and the normal. So this is the angle of incidence. Okay, first angle of incidence I1. Okay, this is the angle of refraction. This is the angle of refraction, that is R1. Angle of refraction R1. Here the angle of incidence, the second angle of incidence is I2. Angle of incidence is I2 and the angle of refraction is R2. R2. Angle of incidence I2 and angle of refraction is R2. Okay. In this figure, EO is the incident ray. Okay. EO. Angle of here EO. This is the incident ray. O dash is the refracted ray. O dash is the refracted ray. O dash is the refracted ray. And O dash H is the emergent ray. O dash H. This is the emergent. This is the emergent ray. Okay. So EO is the incident ray. O dash is the this one. O dash is the what? Refracted ray, and O dash H, this one, is the emergent ray. Okay. You may observe that the emergent ray is parallel to the direction of the incident ray. Okay. The emergent ray is parallel to the direction of incident ray. This is the incident ray. Okay. This is the incident ray. Okay. This is the incident ray. EO. The emergent ray is parallel to the incident ray. Okay. Incident ray. Emergent ray is parallel to the incident ray. Why does it happen so? The extent of bending of the ray of light at the opposite parallel faces AB, air glass interface, and CD, glass air interface, of the rectangular glass slab is equal and opposite. This is why the ray emerges parallel to the incident ray. However, the light ray is shifted sideways slightly. Okay. This is why ray emerges parallel to the incident ray. However, the light ray is shifted sideways slightly. What happens when a light ray is incident normally to the interface of two media? Try to find out. Now you are familiar with the refraction of light. Refraction is due to change in the speed of light as it enters from one transparent medium to another. Okay. Refraction is due to change in the speed. Okay, change in the speed of light as it enters from one transparent medium to another. Experiments show that refraction of light occurs according to certain laws. Okay, so next we are going to discussing about the laws of refraction. Laws of refraction. Laws of refraction. First law. There are mainly two laws of refraction. The first law and the second law. The first law is the incident ray, the refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. Okay, what is the first law? The incident ray, the refracted ray and the normal at the point of incidence is all lie in the same plane. We discussed earlier the incident ray, refracted ray and the normal are lies in the same plane. Yes, we discussed earlier. Okay, that's the first law. The incident ray and the refracted ray. Incident ray, refracted ray and the normal. Incident ray, refracted ray and the normal are lies in the same plane. Okay, are lies in the same plane. This is the first law. Okay, this is the first law. Next, the second law. What is second law? The second law is also known as Snell's law of refraction. Okay, what is that? Snell's law of refraction. Snell's law of refraction. Snell's law of refraction. What do you mean by Snell's law? Snell's law. Snell's proposed the law. So this law is known as Snell's law of refraction. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant. Okay, Snell's law says that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. Okay, we can write that sine of angle of incidence. Angle of incidence is I. Then sine of angle of refraction. So the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. Okay, is a constant. Is a constant. This is the Snell's law of refraction. So the second law of refraction is also known as Snell's law of refraction. The Snell's law says that the ratio of sine of angle of incidence to the sine of angle of refraction is equal to a constant. Okay, the first law says that angle of the incident ray and the refracted ray and the normal are lies in the same plane. Okay, the second law says that the sine I divided by sine R equals a constant. Okay, this constant is known as refractive index. Okay, this constant value is called refractive index of the second medium with respect to the first. Okay, so this constant is known as refractive index. Refractive index of second medium. Refractive index of second medium with respect to first. Okay, this constant is known as refractive index. Refractive index of second medium with respect to the first. Okay, this is the Snell's law. These two are the two laws of refraction. Did you get? The first law says that what the incident ray, the refracted ray and the normal are at the point of incidence all lies. Okay, all lie in a same plane. The second law, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. That constant is known as the refractive index. The refractive index of second medium with respect to the first. Okay. So today we studied the term refraction of light and the refraction through a rectangular glass slab and also two laws of refraction. Thank you.